Josh, I'm going to introduce Josh to you, but you should know that, well, I'm pretty sure you guys all know that he is a Tiger. He was a Tiger, and still is, okay? So Josh was born in Fort Saskatchewan. However, he has ties to Two Hills area and has moved with his family, with his family to Lavalin as a teenager. Prior to living in Two Hills County, he went to school in Fort Saskatchewan, Elk Point, and Whitehorse. Once his father retired from the RCMP, his family moved to the Kutryk homestead, which has been in the family for over 100 years. Joshua completed grades 9 through 12 at Two Hills High School, and in 2000 was the valedictorian of his graduating class. During his time at THHS at the time, Two Hills High School, he joined 4-H Beef Club in Murnum. He played hockey in Manville. He was in the Air Cadets in Mundare, where he received his pilot's license at the age of 17. After high school, he attended the Royal Military College of Canada, and in 2004 graduated with a bachelor's degree in mechanical engineering. Col Kutryk is an experimental test pilot with over 4,000 hours of flying experience on more than 40 aircraft types. Prior to joining the Canadian Space Agency, CSA, Col Kutryk flew as a developmental test pilot for the Royal Canadian Air Force in Cold Lake, Alberta. He has worked on a variety of flight test projects, including out-of-control flying, simulator certification, automated navigation, and weapon guidance development. Previously, Col Kutryk served as a CF-18 fighter pilot flying missions in support of NATO, UN, and NORAD commitments around the world. He has been deployed in both Libya and Afghanistan. Josh Kutryk was selected as an astronaut candidate by the CSA in July of 2017. He completed the 2-year astronaut candidate training program and obtained the official title of astronaut in January 2020. Since then, he has continued to serve Canada's space program as an active astronaut at NASA. He works in different technical and operational positions, including mission control, as a Capcom during spacewalks, and commercial vehicle proximity operations. In 2023, he was assigned to Starliner 1, a commercial crew mission to the International Space Station, where we will live and work where he will live and work for approximately 6 months. He will become the first CSA astronaut to be part of NASA's commercial crew program. So we are extremely excited to have you, Josh, visit our school today. I was talking to you earlier, we're big on our school culture here at Two Hills, and as you can tell by all of our Tiger colors here today that we have flying, we're very proud of our school. We're proud to be Tigers, and we're proud to welcome former Tiger to THS to speak to us. Once a Tiger, always a Tiger has been a saying that we often use and is very fitting here. So I just want to welcome you, Josh, and I want all of our Tigers to please give a warm welcome to CSA National.
Say thanks, thank you. So, you guys, I just have to tell you, it's really nice to be here. This is a treat for me. I don't get to do this very often, which is come to Two Hills, where I went to school and talk about space, which is what I do. So, really looking forward to spending some time with you. I'm going to speak about a little bit about what I'm doing, my story, show you some pictures, do that for maybe 20 minutes, and then we'll take your questions. And I hope that you'll not be shy and feel free to ask me anything at all. Let's see if we can get the next slide. We can just go manually to the next one. There we go. So what am I doing? Well, it's a bit of a long story. I came from here 24 years ago. I graduated from this gymnasium. Did a whole bunch of things since then. But right now I'm getting ready to do this. This is a photograph taken in Florida. And in a couple months, we think, sometime this year, I am going to get on that, and we're going to launch into space. So what you see happening in that photograph is a rocket going straight up. If you've ever seen this happen, it's a pretty violent experience. It takes a lot of energy and power to get a rocket off of Earth. You know, when you watch it from 5 miles away, like in this photograph, it looks like it's going kind of slow. It just lumbers up and up and up, but it's actually going really fast. In the first 100 feet, when it goes past the tower, it's going about 100 miles an hour. And in about 9 or 10 minutes, it's going 28,000 kilometers an hour. And then it just keeps going faster and faster. And we're going to fly that into space away from Earth. We're going to do a whole bunch of weird orbital mechanic maneuvers with it. And we're going to find the space station and move in and then live there for about 180 days. This is another photograph from Florida. You know, I go to Florida quite a bit, so I live in Houston, that's where I work. I commute to Florida maybe once a week or so sometimes, and I get to see stuff like this. I like to share it with young people. You know, if you don't know what this is, these are 2 rockets. They're not actually launching, they're landing. So they've already launched, and they've delivered satellites and stuff for businesses and companies into space, and then they've turned around and they've fallen back to Earth. And at the last minute, they light the rockets. And these rockets are like little mini skyscraper towers, right? And they're going to land perfectly in the middle of those cement pads, and then they're going to be refueled, and they're going to launch again. I've stood in the middle of those cement pads. It's really awesome. The reason this is awesome for me is that just a couple years ago, like when I was starting out, when I was studying engineering, there were people in the world that wanted to do this, but actually most people thought it was impossible, that there were reasons why they'd never be able to. But they do it now, sometimes almost every day. I was in Florida last week, I saw it. Every day or 2 or 3, they're doing this, and it's changing the world. I'm going to back up though a little bit earlier, so we'll go back 35 or even closer to 40 years now, which is hard for me to say, but once I was a kid, like everyone was a kid once, and most of that time was spent here. This is a picture from about 20 miles due east of here, where I lived and grew up, and that's me as a teenager. We raised cattle. Nobody really knows how I got interested in space. I don't either. When I was 6 or 7, I knew what an astronaut was. I wanted to be one, but I held that to myself. I never thought it would be possible. I still feel mostly just lucky to be doing it today. I would tell you that as a kid, I felt always really curious about the world around me, and I wanted to explore. I love reading books about ocean exploring and Arctic exploring, and then space exploring, and I knew that in my head I wanted to do it, but I never really thought that I would. But then I got the flying bug, I got the science bug, I loved physics. I actually just saw someone walk in. I got taught by the best physics teacher in the world, and he's here today. He's sitting in the back, Harvey Hashik. But you know, I love physics, engineering. I wanted to do something with that. I couldn't go into space right away, so I started doing this. I flew everything I could fly. I became a commercial pilot, I think I was 18, and then every kind of pilot I could become. I flew as a fighter pilot for a long time and then went back to school. This will be a common theme. I spent a lot of my life in school to become an experimental test pilot, and that's what I was doing when I was hired. So I joined this group 7 years ago. It's the best group of friends and colleagues that one could ever dream to have. This is the current core of Canadian Space Agency astronauts. So I'm actually still the new fella. I was hired with Jenny. We're in the middle in 2017. Jeremy is on the left. He's flying to the moon in about 12 months from now. We'll talk about that. And then David St. Jacques is on the right. He's the last Canadian to come back from a long duration mission. It's hard to get asked to join this group. Selection takes about a year. It's, you're traveling for a whole year, getting tested, written tests, academic tests, physical tests, medical tests. And you start with about 4,000 or 5,000 people, and the group just keeps getting smaller and smaller and smaller until it's just 2 of you left. I moved to Houston in 2017, joined the Canadian Space Agency, and basically I said it would be a theme. I just went back to school. So I spent 3 years studying at Houston to become a certified NASA astronaut. Spent a lot of time in environments like this, Underwater, we use water because it lets us simulate microgravity. A lot of time learning about spacewalking, space station operations, orbital mechanics, learning to speak Russian. There's a lot to learn if you're going to go out the door and do a long-duration space mission. It takes years and years and years. I finished that program in 2020, and then once you're a qualified astronaut, you're still not really qualified to do anything. You're kind of just qualified to keep learning and to start working. So these are some photos from my day-to-day. I do a lot of technical work at NASA for the Canadian Space Agency, but with NASA, controlling space vehicles, helping to design vehicles. This is me working as a flight controller during the launch, one of the first launches of the SpaceX Dragon 2. You know, if you think of an astronaut, they might have a 15 or 20-year career down there. Of course, very little of that time is actually spent in space. Most of it is spent doing engineering kind of jobs like you see in some of these photos. We're always training. This is training. Some of our training is technical book kind of training, but some of it's like this. So this is a photograph that was taken about 300 meters underground in Europe. We're there with astronauts from Japan and Russia, United States, Germany, Canada. I'm in the middle. And we're alone, and we're just living underground for 3 weeks, and we're doing some pretty serious work. We were mapping that cave system out. We're doing biology research for different universities. But from an astronaut perspective, the 6 of us are there to train, and we're training because it's an environment that's really similar to space in that it's dangerous, there's a lot of risk, you have to be super focused, and you have to learn to get along, and you have to just become good at operating in what we call high-risk, high-consequence situations. So we call that a space analog. We go and we live underground. We go and we live underwater sometimes on the ocean floors. We go and we live in craters in Canada's Arctic. These are all examples of things that I've been up to over the last couple of years. Spend a lot of time now here. So we're getting ready to spend 6 months in space. And the thing about space for astronauts is that it's really bad for you, actually. We'll talk a little more about that, but there's radiation, there's no gravity, your body doesn't handle that well. I'm going to lose a lot of muscle, a lot of bone, my brain's going to change, all that kind of stuff. So right now, we're in the stages of doing a lot of work to prepare the human body to be able to take some of that, and we'll continue to do it during the mission and after to recuperate, hopefully, to the same human body and being that I am today. I still fly a lot. I fly this airplane quite a bit. It's the NASA T-38. We use that at NASA to keep pilots proficient like me. We also use it for everybody because, again, it's kind of like the cave picture. It's a good way to force people to work together who might come from very different backgrounds in an environment where there's a lot of risk. You have to be really careful. It exposes folks to high G and high speed and all of that. Spend a lot of time in the water. These are just sort of day in the life kind of pictures, but this is in one of the pools down there, and this is a Starliner spacecraft, and what we're doing is practicing getting out in the event that we landed in an ocean. Starliner is actually pretty neat. It's not supposed to land on the ocean. A pilot in this spacecraft can fly it to any point on the ground. We could land it in a field outside Two Hills if we had to, or if we had reason to, which is pretty cool. It's new technology. It hasn't been used before. But we have to be ready to land in the water because if you think about a spacecraft coming back to Earth is different. It's just a ball that you're trying to hit. And A, it's pretty hard to hit it and not miss it. But B, from the perspective of astronauts flying the spacecraft back, Earth is mostly water. And so if everything goes just perfectly, we hope to land on the land. But if something doesn't go perfectly, there's a real good chance we end up in water somewhere on planet Earth. And so that's one of the things that we're practicing here. It's all getting ready for this. And so this is the mission patch that the Canadian Space Agency released a little while ago. It's for the mission that I'm going to go fly. And of course, I say I'm going to go fly and my name's on there, but it should go without saying I'm just the person who gets in the seat. I mean, this is a mission that hundreds, thousands of people from the Canadian Space Agency, from Canadian universities, companies, industry have been getting ready to do for quite a while. It's going to be the 4th time that Canada sends a Canadian into space for a long-duration exploration mission. So that's 6-7 months in outer space. And you see things on this patch that are important to us. But one of the things that jumps out the most is the red flag. It's the same red flag, obviously, that I have on my shoulder all the time. And that's an important piece. This will come back up in a few more minutes, but Canada does a lot in outer space that a lot of other countries don't do. And in fact, if I don't think you'd find in the world another country with the population that Canada has who's doing in outer space what we're doing right now. And that's a pretty good thing. We take a lot of economic and health and industrial commercial benefits from that, and it's something that also is giving us a lot of opportunity. I mean, there's a Canadian going to the moon next year. The first person who's not American to ever go to the moon is going to be a Canadian, and that says a lot about what we do in this country and what we do well in terms of science. A picture of the International Space Station. So this is where I'm going to go with a crew of 7 total. So there's 3 astronauts who are going to launch from Russia, 4 who are going to launch from the United States. I'll be among those 4. We're going to meet there. We're going to go in the front door. We're going to take it over. And then we're going to start running it and doing science there. So this is the ISS, as we call it, International Space Station. Probably the most complex thing I think that humans have ever invented. Made from an international partnership, really. United States, Russia, Japan, all of Europe, and then Canada. And it's really a floating laboratory where a lot of science gets done. Now, I think, for perspective, I would point out everything you see in that photograph is pretty big. That's about the size of a football field. It was assembled with about 100 different space launches, so millions of components had to go up over 100 different launches, 20 years, get put together. Everything in there is moving at that velocity point, 28,000 kilometers an hour. Always has been, always will be. It's in perpetual orbit. And then the astronauts, of course, live in there and work on the outside of it as required. This is a picture of Canadian Space Agency astronaut Dave Williams a couple years ago. In this photograph, he's helping to construct the ISS. You see some Canadian robotic technology. Canada, has always done this well. We make things in Canada that no one else in the world knows how to make, and then we give them to NASA. And one of those things is something you see in this photograph, that robotic system. So we make it in Canada, we make companies around that, we make industrial bases around that, and then we give it to NASA, and in return, NASA lets us do things like this. They let us fly there, they let us partake in the science and the discovery, and of course we get all kinds of industrial and commercial benefits from building that technology. More pictures of Canadian stuff on the ISS. This is called Dexter, and it doesn't get talked about much, but that robot, it's like a hand with 5 fingers. You can see some of the fingers. It's about the size of a 3/4 ton truck. It's totally autonomous, and so it is always working 24 hours a day, crawling itself around space station like a giant hand, and doing work autonomously, taking out computers, putting in new computers, that kind of stuff. This technology is still basically unique to Canada. No one else knows how to do some of this stuff, and that's why we get to partake. Human spaceflight, my mission is all about this. It's all about the human body. Here's David St. Jacques doing medical research. I like to tell people, when an astronaut goes to the ISS for 6 months, they do 2 things. The first is run the ISS. Hugely complicated, takes 7 years to learn how to do that, because we have to be able to fix everything, every computer system, inside, outside, do the spacewalking, fly the space station. There's no one else there who's going to do that or fix it. But the rest of our time, we're doing medical research, and you see that here. Space, I already told you, is really bad for my body, and so that's not a good thing for me. But the good thing for science is that makes it a really good environment for doing medical science, and we do a lot of that. I've spent years now learning to do this science for researchers from around the world. Being in space, one way to think of it is it's like aging. So we all age on Earth, and if you might age 10 years here, there's certain systems of mine, like my skeletal system, for example, that might age the equivalent of 10 Earth years in a month on ISS. So it's bad for me, but it's really good for doing science, for studying things like cancer treatment and aging diseases, osteoporosis, examples like that. Space station, just pictures from inside. The total volume that astronauts have to live in is probably the size of a small, average Canadian house, but it doesn't look or feel like a house. It's all tunnels and round modules. thousands of miles of wiring everywhere, computers everywhere. It's kind of a real mess. There's no up, there's no down, left or right. Everything is just floating around. So it takes a long time, a lot of training to learn how to function there. This is the biggest window on ISS. That's my good friend Tracy looking out of it. And of course, astronauts are lucky because they get to do this. They get to see the Earth as a blue ball. But more than that, I would tell you that ISS and what we're doing in space lets everybody see Earth as that blue ball, as a single planet, instead of as a mix of countries maybe. And that's been a good thing. Space has brought countries of the world together that have never really worked together before. And Russia and the United States is probably the best example of that right now. They're still cooperating in space. I work with Russian cosmonauts, but of course we're not seeing that cooperation anywhere else. So space is pretty valuable for that. I'm going to go to your questions here in a minute, but at the end I want to tell you where this is all going. So we've spent 20 years with the International Space Station that you see at the bottom, learning how to keep humans alive for, like my mission, 6 months or even a year at a time. We couldn't do that 20 years ago. We know how to do it now. And NASA is about to take the next step, which is take that idea and go all the way up to the moon. So we're making a space station around the moon. And I think that in the next 4 or 5 years, you're going to see humans working, living around the moon and on the moon, doing science like we do on the ISS right now. The point, of course, the ultimate objective is to go all the way out to Mars. And I think that Mars is something you might see in your lifetime if we're lucky. I think that that's something that could happen. The first person to walk on that planet could be alive today. Somewhere on Earth, they're not me, they're a lot younger than me. A little bit about these guys, wonderful people. They're all close friends of mine in Houston. This is the crew of Artemis 2. They're going to blast off next year for a short mission, but a very, very special mission. It's 10 days to the moon. And this will be the first time that anyone's gone to the moon since Apollo. These 4 people are going to go farther and faster than any human being's ever gone in the history of human beings. But the neat part that I want to point out is that this is mostly an American mission. So there's 3 American astronauts, and then Jeremy, who of course is from the Canadian Space Agency with me. And that's pretty special. I mean, that's from the entire world. There are, as you can imagine, tons of countries in this world that would kill to be on that mission, this historic mission. Yet from the entire world, from all the countries that the US works with, it's our Canada that is taking that seat. And that's not a coincidence. That's because of what we do in Canada. That's because of the young scientists, engineers, teachers, the industrial bases, all of that stuff. It's because we have people in Canada who innovate in ways that we don't see elsewhere in the world. That's why we have that seat, and that's why we're trying to keep this thing going. I think in 4 or 5 years you're going to see this, bases on the moon, people doing research on the moon. This stuff is being built right now in Houston, designed. It really is coming. So you're growing up into a pretty exciting future, I would say. And at the very end, I show you 2 pictures of Earth. So this is our planet, our home, obviously taken from space. It's actually Canada. For those of you who are geography savvy, you'll see Vancouver Island and the western coast of BC stretching off to the east. Most of Canada's there, but it's underneath cloud. Space lets us look at Earth, and that's pretty important. I'm always talking about what humans do in space, but we have hundreds of satellites, and the Canadian Space Agency is involved with many of these, doing other kinds of things in space, helping our phones work and our banking work, and forecasting the weather, and reacting to disasters, monitoring forest fires, fighting climate change. This is all stuff being done from space, with space infrastructure like satellites. We really have and are moving into this environment of space because it's an opportunity for us to solve big problems on Earth. So this is that picture, and this is almost the same picture, just a little different. Instead of taking this picture with a normal camera, this was taken with synthetic aperture radar, we say, which is just a fancy term for a technology that was also invented in Canada, is being used all over the world to help farmers, to help fishing people, to help with natural resources. But I like this photo because it shows us Canada in the way that I think of Canada, which is, you know, the most special, unique country in the world, the Canada that I know, the true, the north, and the free, that lets us do things like this which is send Canadians to space. So in closing, I've always said I feel just so darn lucky and excited to have this job, to be representing Canada, to be working for the Canadian Space Agency. I feel really special to be doing the job with a Canadian flag on my shoulder, because that's special. There's not a lot of countries that get to do that. So, some pictures from my life. Thank you for listening. I want to give the mic back to you and take your questions. Please ask me anything. Don't be shy. Thanks, guys. We have a lot of programs for engagement at the Canadian Space Agency. This is one where we actually take problems that Canadian Space Agency engineers are working on, and we give them out to schools across Canada, and we see what their ideas are they come back with. But you can find all of that here at our website. So we'll leave that up. And how would we like to do questions?
I was just going to call up, we're going to start with our youngest students to ask you some questions, and we're going to move our way up. So we had some questions kind of for each age group. So let's start with Corey, Shreer, Lexi, and Jaden. If you could come up to Mr. K.
Hi guys.
Okay, you guys can just stand right here and we'll start. You guys have your questions ready? Okay. Shreer, let's start with you.
I have question number 1. What do you drink?
What do you drink?
Yes.
Good question. The question was, what do you drink in space? And drinking in space is pretty hard. You can't just, if you have water out in the open, it forms a perfect ball, like a perfectly small spherical marble, really, and it floats away, you lose it, and it causes all kinds of problems. So most of the time, we drink out of bags. We have water in bags, we jab a straw into it, we squeeze the bag, squeeze the water straight into our mouth so it doesn't go anywhere else, swallow it immediately so we can keep track of it. We drink from plastic bags. Great question.
What clothes do you pack, and can you wash them in the space station?
Yeah, thank you. He's asking about clothes on space station. I haven't been asked that in a while. We have very few clothes. It costs like $10,000 to launch, a suitcase of clothes to space station. So we wear the same clothes over and over and over, sometimes for 4 or 5 weeks at a time. And when we're done with them, right now we actually can't wash them. So they end up as garbage, and they end up burning up in the atmosphere is what happens. We put a new t-shirt on and we wear it for as long as we can, 5, 6 weeks at a time. Space actually is all about that. It's about being as good as we can with the amount of resources that we use. So with water, we're always trying to recycle. With clothing, we're always trying to wear the same shirt and never change it because we don't have a way to wash it. Good question.
All right, Jaden, are you ready?
How much oxygen is in your tank if you go outside the space station?
Jaden, nice pin. Where did you get that from? Awesome. This pin. CSA. They're miles ahead of me. Jaden's question was how much oxygen is inside your tank when you go outside the space station? I say it's kind of like how much jet fuel is in my airplane, and the answer is never enough. But with the spacesuit, it's about 7 hours. So we can go outside for 7 hours before we run out of oxygen. And they better be inside when you run out, because there's nothing else to do at that point.
All right, and Lexi.
Will you be able to FaceTime your family? Yes.
Can you FaceTime from space? And you sure can. The International Space Station now, Alexei, has internet just like you would on the ground. It's complicated. It uses $1 million satellites that are moving at super warp speeds all over space. but they get it done. And when all of that's working, I can, just like you can, get on the internet, make a FaceTime call. I can pick a phone up, actually, and call pretty much any number on Earth. So, yeah, we can.
Awesome, thank you. That's our grade 1 to 3 students. And if we could have our 4 to 6s up, so that's Braden, Avery, Aiden, and Darian. Come to this side. Oh, okay, sure. All right, let's go youngest to oldest. Braden, you're first. Are you ready? All right.
What cool experience do you have since becoming an astronaut?
What cool experience have I had? You know, every day as an astronaut, there's a cool experience. And that's why I just feel so lucky to have this job. If I had to think of one for you, I showed you that picture from working on caves, doing research underneath the ground. So we didn't get to see sunlight for 3 weeks, and it's a place where if you shut your light off, like it's as dark as you can ever possibly imagine. You can't see your hand in front of your face. And there was one time where I ended up, by the plan, getting left behind. I was all alone in a part of this cave. And I went about and I just sat there for like 10 minutes, and then I shut every single light off. And I was just in the most uniquely alone, dark place that, like I say, you've ever even been able to dream of. Just absolute, pure isolation and darkness. And that's a memory that will always stick with me. But really in this job, I mean, on a day-to-day basis, you're in jets, you're underwater, you're in spacesuits, you're in simulators, you're underground. There's a lot of cool experiences, and that's why I like it. So appreciate your question.
All right, we have Avery in grade 5.
What is your favorite part about being an astronaut?
My favorite part about being an astronaut, and I'll give you a little bit more detail on this one. So I like being an astronaut because I get to live and work on the forefront of human technology development. And I think that that's important. It's always been important. If we look in Canada, or if we ever look at the world, historically, we've always had to keep going, keep progressing, keep inventing new things, finding new ways to cure old diseases, finding new technologies. I mean, we did it with boats, and then we did it with airplanes, and now we're doing it with spacecraft. But it's important to keep going. It's important to keep looking on the horizon, seeing things that are impossible one day, and then working with teams to try to make them possible. And that's what space is about. That's what we're doing in outer space right now. And that's what I've always been most fascinated with. As a kid here, I wanted to work in technical fields where we were pushing boundaries, pushing technology forward. That's what I get to do as an astronaut, and for me, that's the most rewarding part. Thanks.
All right, we have Darian in grade 6.
What do you have to learn or do to be able to run the ISS?
What do you have to do to be able to operate the International Space Station? So if you take all the training that someone does before they go there for 6 months, we don't typically do it back to back to back, but if you put it back to back to back, it'd be about 6-7 years. So that's how much there is to learn. A lot of it is technical, so you have to understand the computer systems, how they all work. You have to be able to maneuver the ISS. You have to be able to get in the spacesuit, go outside. You have to be able to fix everything, and you have to be able to do all the science. And to give you some numbers on the science, right now, today, there's about 3,000 science experiments underway on the International Space Station. And the astronauts, of course, some of those they're running directly with their hands. Some of them they're just watching, but there's a lot of stuff to watch over. And so you have to also learn all of that science. And that's why the timeline is so long. That's why you end up studying and learning for years and years and years before you go to do it. There's just a lot to learn. Good questions.
All right, Aiden just woke up, he says. Aiden in grade 6.
Why do you like physics?
The question was, why do I like physics? Physics is you know, if the world is a house, physics is the foundation, right? Physics is the foundation of everything that we know how to do. And I remember being in high school and just being introduced to really early elementary kind of high school equations about like gravity, for example, and how in high school as a grade 10 student, I could, with an equation that had just 3 or 4 terms in it, I could do so much. I could tell you how far a ball would fly before it dropped to the earth, which is basically what an orbit is. And to me, that was just this mind-blowing realization to see that physics and math, which is kind of the language of physics, can predict everything around us. And it's the thing that has led to every invention that today in 2024, 25 is changing the world. I mean, the big stuff like space rockets, quantum computing, artificial intelligence, these all have roots in physics. So physics is the thing that is changing the world, that's going to make the world better, that lets us understand the world. And that's why it was my favorite subject, and I think still is. Great question.
Okay, you guys had just one question each, right? Yeah. Okay, you had more? Okay, let's do one more round. Do you have another one, Brandon?
What focus of your next space station?
Brandon asked, what's the focus of our next mission? The real focus of this mission is science. And, you know, I talk a lot about running the space station. That's just something we have to be able to do so that we can stay alive and do the real job. The real job is the science. So we're researchers, and the science, I would tell folks, is really broken into 2 main categories. A lot of these 3,000 experiments are about space exploration. So we're doing science that we need to do to figure out how to go to the moon and live there, and then someday how to go to Mars and live there. So we're doing science with things like combustion and propulsion techniques and communication technology, things that we need to figure out to go further into space. That's the first part of it. But the second kind of science that we're doing, which you saw in my photos, is all the science that has nothing to do with space. It's all related to solving problems on Earth, and most of that science has a medical flavor to it. So we're studying the human body. We're using space station because it's a lab where we can do science that we can't do anywhere else on Earth. The experiments we do on space station can't be done on Earth. They can't be done where we have gravity and all the other things that we have down here on Earth. They need to be done in space. And so that's why we do the medical research there. But the real focus, the real reason Canada's sending someone for 6 months in outer space on this mission is comes down to scientific research and discovery. Yeah. Great question.
How many years did you have to go to college and university?
She asked how many years did I study in university, and a lot. So I have an undergrad in, say, mechanical engineering out of high school, and then I have 3 master's degrees. So I studied flight test engineering, I studied Master of Science, Space Studies, and then I did something that wasn't really related to space at all. It was defense studies and global strategy stuff. But a lot of years. And, you know, I graduated from here 24 years ago, and I want to tell you something about that. I liked school, and I liked studying, and I knew without a doubt that I was going to go into university for sure, because I was passionate about that. It's not for everyone by any means, but it was for me. I liked studying. However, when I was here as a grade 12 student, I never in my life thought that I would spend as many years in postgraduate school as I did. I knew I was going to get an undergraduate degree, but I really didn't even think I'd end up getting a master's degree, and I ended up doing 3 of them, and that's just such a neat thing that happened to me. Like, I remember sitting here in grade 12, and like 12 years in school seemed like an eternity. Another 4 years in school seemed like an absolute eternity, an impossibility. And then to think about doing more school past then seemed like just an absolute silliness. But somehow the way it's gone, I've more or less been in and out of school my entire life, and I've loved every minute of it, and I'm really grateful for it. So yeah, it's just weird. Your perspective on all that changes as you as you get older. The years become less.
Do you get paid to be an astronaut?
Not enough. She asked if I get paid. Yeah, I get paid. It's a pretty normal job though, from, you know, aside from the part where you get to go and work there, it's a pretty normal job. So like in all seriousness, I'm a Government of Canada employee, work for the Canadian Space Agency. I've been a Government of Canada employee basically my entire career in the Air Force and now in CSA. So I'm paid as a normal, now, you know, pretty seniorish Government of Canada employee, and it's enough. But there's really nothing special. You know, sometimes folks are always think that we get paid all this money or that we're rich or something because we take these risks, and there's nothing like that. We're just a very normal run-of-the-mill government employee. Yeah.
All right, thank you, grade 4 to 6s. If we could have up our 7 to 9. So Lisa, Kaysen, Ivan, Merrick, Alira, and Zane. Come on up. All right, let's start with our grade 7s. Lisa?
Hi. Is there any set training schedule before you have to go to space, or is there any anti-gravity training?
Sure is. So, questions about set training schedules. I'm on a really regimented training schedule. More or less every day, every hour of my day right now is controlled. What I get to do this week is like a little break. This isn't normal for me, but every once in a while, we take a break, we come to Canada, and we do stuff like this. We go to universities, businesses, schools, talking about the mission. But normally, I'm in Houston training, and we're around the world. We train in Europe, we train in Russia, we train in Japan, to name a few examples. We train in Canada. But most of that's very controlled, so I have a schedule, and I just follow it day by day, right down to the minute by minute. You asked about anti-gravity training, and we do a lot of that. We do it in a couple different places. We do a lot of it underwater, so we use neutral buoyancy to feel like we're in microgravity. That's where we do the spacewalk training. But we do gravity training in other places as well. So we fly parabolic flights, which is where we all get in the back of a big kind of airliner style airplane. And the pilots up front take the airline, and for the full hour, they just do this, which is more or less straight up, and then push over straight down, straight up, straight down. That's the way the whole flight goes. It's kind of a little bit miserable, but the good part of it is that at the top, where you're going from straight up to straight down, you get 20 seconds of microgravity. And so we do that. We use all kinds of simulators. We use virtual reality to train microgravity. And what else? We use centrifuges as well. So centrifuge is like a gym like this with a big machine in it, a great big pendulum. I get into a cockpit, strap all in, everything closes down around me, everybody leaves, and it starts spinning faster and faster and faster and faster, and they can simulate all kinds of different gravity profiles with that. They simulate the gravity profile that we're going to feel on launch. They simulate the gravity profile that we're going to feel on re-entry, right down to like the swing of the parachutes and the impact into the water and all of that, to give you some examples. But yes, we spend a lot of time training with different evolutions of gravity.
All right, let's have Case in grade 7.
What do you do in your free time?
Free time. Yeah, what do I do in my free time? I try not to work. I've always had, I have a family. I have 2 small kids. I don't have much of a social life, but sometimes I do. I think I've always liked to do things alone, to be frank with you. If I really have free time, I'm probably reading a book or I'm riding my bike. I'm a road cyclist. I spend hours a week riding bikes and thinking and just getting healthy. So those would be the 2 big ones right now, reading and bike riding. I read mostly like historical fiction kind of stuff, but I love reading. My entire life I've had a book beside my bed, and my entire life I've every day done something physical. Right now most of that involves biking. But those are two things that have been with me my entire life, and I think and I hope always will be in terms of free time.
All right, Merrick in grade 8.
What do you hope to achieve by going to space? Like, what's your biggest goal?
My biggest goal, I got a couple big goals. I mean, part of it is the science. So we have some experiments at the Canadian Space Agency that we'll be working with and trying to make successful. One of them is basically, it's pretty hard to do, but it's like a little black box that would fit in your hand. And what we're trying to do, what these scientists are trying to do is create a device where we can take a drop of blood from you, just a little pinprick, put it into this super complicated device, and then learn everything we need to know about you and what we need to do to you right now, if it's give you a Tylenol or do an operation. So that's a technology that we're working on. We need it to go to the moon. We also need it for places like remote communities in Canada. So there's a lot of investment behind it. There's a lot of scientific horsepower behind it. You know, if I could be helpful in getting something like that to work and prove it on ISS, that would be a major objective. We're also flying a new spacecraft, Starliner. We're trying to help get that working, tested, developed. So that's a secondary objective, I would say, that's pretty important to me. But you know, those are the specifics. In general, it's about making new scientific discoveries and inventing new things that we can use. What are you doing?
All right, we have Ivan in grade 8.
Do you have any fears of going up to space, and how do you train to overcome those fears?
That's my mom, and so for anyone who doesn't believe I grew up here, I know there's tons of people in the crowd I know. It's my mom, my physics teacher, our counselor, my aunt Cheryl. Fears about space. So I would tell you that I have fear. I think that if you get to the point, and this is true for a couple things in life. I mean, I've made a career out of doing things that sometimes people find scary and that I found scary. But I think that if you get to the point where you're doing that thing, whether it's testing an airplane or launching on a spaceship, if you get to that launch pad, if you get to the rocket and you're scared, what I say is you shouldn't be there. You're not ready to be there. There's more that you could do, and that's what space training is all about. It's trying to do the preparation and the training, really, so that when you get to launch day, you're not scared. If you get there, you're going to be nervous, but if you're scared, I think there's more you could have done to prepare. That's what I tell myself anyway.
All right, we have Alira, grade 9.
How do you balance your home life along with your work life, and is it difficult to do?
Lyra asked about what grade are you? What grade? Okay. Yeah, you're gonna discover this real soon. But that's for many people, that's the hardest part of life in general. And if you're an astronaut, that's definitely the hardest part about life. It's not the studying, the technical stuff. It's about what your question is, which is finding the balance. I already told you I've got family, I have kids, and if you're an astronaut, you'll find that you have a ton of different people who want your time, need your time, a ton of different priorities, and nobody tells you how to manage that. That's for you, and that's the hard part about the job. I think that, you know, it's a skill that is practiced. I've been practicing it my whole life. It's a skill that is based on the fundamental of discipline. So you're not going to succeed with that unless you're disciplined. And now, by the way, is a perfect time to start approaching your life with that discipline. But you just have to be super, super disciplined. I mean, you have to tell yourself in the morning, I'm going to do these things today. This thing's going to be done between 8 and 9, and at 9 o'clock, if it's done or not, you're done because you have to move on to the next thing. When people don't have that underlying discipline, they start to have problems, I find, with the work-life balance. But if you can stay disciplined, recognize the importance of everything else outside of work, the importance to you, the importance to other people, then you'll find a way to balance it no matter how hard it is. But you got to start practicing the discipline part, the decision-making part early in life. And I think that's what I've been able to do.
And we have Zane in grade 9.
How significant of a dedication is to become an astronaut, and what are some of the sacrifices you had to make?
Difficult. It is difficult. Selection was really difficult. Selection is a year of testing, and you always feel like you failed. You leave every test convinced that they're going to call you and tell you you're cut. But if you're lucky, you just keep going. So it's certainly difficult. Life leading up to selection is difficult because you need all, the tons of education, you need the operational experience. So it's difficult, but I think, what I would tell you is that if I look at the folks I work with, so in Houston, I'm on a floor with about 50 astronauts from all over the world, and they're all people from very different backgrounds who have had this kind of difficulty, I suppose, in their life because they've done a lot of things. But they're really different people. We have some pilots, but we have engineers, physicists, doctors, we have teachers, we have veterinarians, geologists, all kinds of people. But they have a couple things in common. And one of the things they have in common is that even though on the surface their life looks like it's been difficult because they've done just tons of school, and they talk 3 languages and all this stuff, they wouldn't tell you that it was difficult. To them, it's been fun, it's been positive, and it's been something that they have enjoyed doing it, which is why they've been doing it their entire life. And so somewhere in there is the secret, which is, taking the challenge of all getting that education, getting the professional experience, and doing it in a field that's fun to you, doing it in something that you can be super passionate about your whole life. You want to get to the point where work doesn't feel difficult, work is fun, and I've been able to do that. I feel really lucky for that. It looks difficult to others, but it's been something that's just been so fun, something that I'm so passionate about that it hasn't felt hard all the time. It's felt like fun.
Awesome. Thank you to our 7 to 9s for your questions. And if we could welcome up our grade 10 to 12. So Jordan, Haley, Phoenix, Shaylin, Quentin, and Georgia. Come on up nice and close. All right, let's start with our grade 10s. Jordan.
What was the most unexpected challenge you faced in becoming an astronaut?
It's an easy one. Most unexpected challenge, learning Russian. Very, very hard. I speak English, I speak French, Russian. I've been working on learning for 7 years. It's a work in progress. I think it's a lifetime effort. But when I was in university thinking about how much I would love to be an astronaut someday, I was not thinking that was going to be part of it, even though it was obvious at the time. But learning another language as an adult is very, very hard, been very unexpected. And I would tell you that we all have those things. So we all have different backgrounds. For me, I'm someone who's been operational, the test pilot thing. I like the technical stuff, procedures, emergency simulations, all that. The language has been a part that's been hard. You might get another astronaut up here from a very different background, and they'll tell you a totally different answer. But everyone has their thing. They have a thing that comes really easy to them down there, and they have a thing that they really have to work at, and that comes harder to them. Good question.
All right, let's have Haley, grade 10.
Based on the images from the James Webb Telescope, do you think we'll be able to explore other galaxies?
I love it. Based on James Webb, do you think we'll be able to explore other galaxies? Other galaxies, I hope so. I think so, maybe someday. I don't know. I would tell you that space in general has this habit of taking things that we never thought were possible and making them possible. I do think we're going to explore other planets with people. I do think we're going to be in Mars in a decade or 2 or 3, but that sort of thing's inevitable. Galaxies with people sure seems like something that's impossible today, but by the same token, if you went back 100 years and tried to talk to someone about quantum mechanics or even something much simpler than that, tried to talk about like an iPhone, for example, I don't know, it might have felt almost just as impossible. So I wouldn't rule it out. And you know, you mentioned James Webb. James Webb is another thing that Canada helped to build. And James Webb, I think, is going to completely change our understanding of ourselves, right? I get asked a lot, do you think we're going to find life? And, you know, be it life right now, be it life in the past or the future, when you look at the size of space from a geography point of view, physical point of view, but also from a time point of view, we have James Webb now looking billions of years back. Yeah, I think it's kind of maybe only a matter of time, so stay tuned. Probably pretty exciting discoveries up ahead.
All right, let's have Shaylin in grade 11.
What was your most fondest memory at THS?
Fondest memory at THS? You know, I always have the memory of graduation because it was graduation, and it felt really good to be coming from a small school like this and going into a big, exciting world, and at that point in my life doing exactly what I wanted to do. It's also a unique memory for me because I wasn't here, and that's another story, but I had actually already left and started training at university, so I was here virtually, and this is in 2020 when virtual looked very different than it looks like today, but I was here on a screen, basically on a video recording, and that was always just a unique memory that somehow felt really good. Felt really good to be saying bye to those people. It felt really good to be coming from this spot, but it was just a unique memory that will stick with me because of how we did it and how I wasn't actually here in person.
All right, Phoenix, grade 11.
What's one regret that you have in your years of THS?
One regret. I have regrets, but not many, honestly. And let me think about that. I've always tried to live life in a way that I wouldn't have a regret. So for example, Astronaut. I always thought I wanted to do it, knew I wanted to do it, never thought I would do it, and I still say you have to, in addition to everything you have to do, you have to be lucky. And so when I was in high school, I would work on that from my own mental point of view. I would say, I'm going to try to do this, but I'm not going to be disappointed if I don't. And on that same token, I can tell you, I've never done anything just because I thought I had to do it to get this job. Everything I did, every decision I made, school I went to, I did because I had other reasons to do it. I wanted to do it. And so it goes to your question. I have tried to make decisions in a way that I wouldn't look back and have regrets. Now, that said, of course I have a few. I think if I think about my own education, what I'm doing now, my own training, I regret not, I already told you the hardest thing for me is learning Russian. I regret not working on language more as a kid. I mean, I was super focused on physical stuff, sciences, physics, chemistry, engineering, all that stuff. But it wasn't until later, even with French, that I started to take language really seriously. I kind of wish I would have got into that as a younger kid. That's one simple one that comes to mind.
All right, we have our grade 12, so we'll start with Quentin.
How long does it take you to put on your spacesuit when it goes to outer space?
Quentin, in the NASA shirt, asks how long it takes to put the spacesuit on. It's a long time. The spacesuit is super complicated. It's almost like an airplane. It has to keep you alive, provide oxygen, take out CO2, keep you warm when it's minus 250 outside, all this stuff. And so the final result of that is that it's really, really heavy. It weighs about 300 pounds, and it's hard to get on. You can't do it by yourself. So when we're doing a spacewalk, we actually start about 6 hours before we go outside the door. And when those 6 hours start, I mean, we put long underwear on, but then we have other people helping us, and they put legs on one at a time, boots on one at a time, all these latches, all these safety checks. You start breathing 100% oxygen because you have to start getting ready for the pressure change so that you don't have physiological problems. You have to do purges. You have to check things 1,000 times and make sure everything's working. Because if you go out the door and the smallest thing stops working, you probably perish. So it's a super serious thing. It takes hours. It takes 5 to 6 hours from someone starting to put the suit on to them going out the door and starting to work.
And finally, we have Georgia.
If you could bring anyone famous to space that isn't already an astronaut, who would it be and why?
People who travel with me from the Canadian Space Agency know this, because I say it every day. Every day somebody asks me a question I've never been asked before, and that's hard for me to answer. And today you get that award. If I could take somebody famous, who would I take? I would, I want to say I would take my kid. That's what I want to tell you, Peter. He's not famous, but he'd love to go. And then maybe he'd be famous because he'd be the youngest one to ever go. So I'd say that. On a serious note, if I had to take someone famous, I would take someone from Canada who is really influential. I'm thinking like Governor General, Prime Minister, someone like that. And the reason I take them is because I would want to show them that window view. I really believe in the bottom of my heart, and everyone at the Space Agency will tell you the same thing, that space is our future opportunity. We have to do it. It's where our inventions are going to come from, our science is going to come from, it's where Canada's future prosperity is going to come from. It's like we're talking about the railroad or something, in generations, centennials back. So it's really important, but of course, not everyone gets to see that perspective. Not everyone gets to see the perspective we get from Houston, the perspective we get from space. And we're always trying to tell them about it, but words only go so far. So if I could really take anyone, I'd take one of my loved ones. If I had to take someone famous, I'd take someone important who could make a difference and make sure that we keep doing this right.
All right, thank you to our grade 10 to 12s, and thank you everyone for your questions. Those questions were actually, we have maybe one more question.
Hi, do you remember your physics 30 grade?
She asked if I remembered my physics 30 grade. Harvey, do you remember my physics 30 grade? It was,
we can look it up.
It was like, you seriously want to know? I think it's mid to high 90s. But it was without a doubt my highest grade, I think. Yeah, I studied physics hard. I liked it. So it came easy to me. Thanks.
All right, so Josh, those questions were actually developed by a bunch of our students, and then the brave souls that got to come up were the ones that kind of were volunteered to be in front of everyone. So those kind of came from a little bit from everyone, not just from the students that were up here. That kind of brings us to the end of our question stuff. Did you have any wrap-up thoughts that you wanted to share with us?
I just want to say thanks again for letting me come out and be at this school again. It's to come here 24 years later and to come here wearing this suit is a fun time for me, but it's more than that. It's inspiring to me. They tell me that I come to schools to inspire young Canadians across the country, and that's certainly part of the job. But when I come to a school like this, I leave inspired myself because I see kids who are kids like I was. You're literally in the same gym as I am. But beyond that, it's inspiring for me to see that in Canada we have this. We have young kids growing up who are interested in space, even at these ages, who want to sit here quietly for an hour listening to someone in a blue suit talk. That's inspiring to me because it bodes well for our future, and I can't wait to see what everybody grows up to be. The final thing I would say is thank you for your attention. We do speak to a lot of schools, and it's hard to hold young people's attention, but I gotta say, you guys have done you've been an absolutely perfect group. I don't know how you did this. When I was here, we were not like this. No one would still be in their seat when I was here, was my recollection. So good job, and thank you very much. Thanks, everyone.